Hello and welcome to Circuit Crush TV. I'm your host Brian Jenkins, and this is Arduino tutorial number 4. Now, last time we took a basic overview look at the board and some of its features. This time we're going to take a closer look at the Arduino Uno board, specifically the power supply part of the board and powering the Arduino. Because powering the Arduino is something many of us put little thought into. Most of us just simply grab our wall wart, jam it into the Arduino's DC jack, and go to town on whatever it is we're working on. The Arduino Uno's built-in power supply is one of the least appreciated but most important parts of the board. In fact, if your Arduino-based creation is giving you weird or spurious errors and you can't figure out why, there's a good chance the power supply could be the culprit. Here we see the power supply section of the Arduino Uno board. As we can see, the input power can come from a few different sources. We have the DC power jack, which is center positive in the lower left. We have the USB connector on the upper left, the silver thing. We have the V-in header socket and the 5 volts header socket. If you plug in both a DC power adapter, like say a wall wart, and a USB cable, the board automatically draws power from the source with a higher voltage. There's a small FET or field effect transistor to the left of the crystal that isolates the USB power from the DC jack to prevent it from backfeeding into your PC's USB port. Also, there's a series diode that prevents reverse polarity from the DC jack. Inadvertently reversing the polarity can destroy the board. Now, the Arduino headers include 3 power outputs: V-in raw DC, 5 volts regulated, 3.3 volts regulated. V-in is an output in the sense that the socket connects to the 5 volt regulator, which powers the 5 volt header socket and the rest of the board. But a word of caution is in order here. V-in is not protected by that series diode we mentioned earlier. It connects downstream of it, so swapping ground and V-in will ruin the board. When powering the Arduino, there is more than meets the eye, at least at first glance. Now, you'll notice 2 capacitors near the DC jack. The one on the right stores energy for power arriving through the DC jack. The specs on the Uno say that you can use up to 20 volts to power the board. The problem with that is these capacitors, and this particular one at least, are only rated for 16 volts. As you may have already discovered, electrolytic capacitors can fail rather catastrophically when their polarity is reversed or when pushed beyond their voltage limit. Now, note that some of the Uno boards out there do have capacitors with a higher voltage rating. Low-quality wall warts often have unregulated outputs that can exceed the ratings on the case, especially at lower current, so be careful with those. And if you have a board like this one with the 16-volt capacitors, one possible hack could be to replace the caps with ones that boast a higher rating, say 25 volts. The caps are 47 microfarad electrolytic capacitors, and this could be a good beginner's Arduino project and also a good insurance policy on your board. Just above that DC power jack lies the Arduino's 5-volt regulator. Now, this device has a dropout voltage of around 1 to 2 volts depending on the load. Now, what that really means is that regulator is going to take up 1 or 1.2 volts. So what it means is it's going to require DC input of at least 6.5 volts to ensure that 5 volts comes out. Because again, 1 or 1.2 volts is going to get lost in that regulator. Here are the power-related specs right from the Arduino website for the Uno. Note the specs on the voltage limit says 6 volts on the low end is okay. Also note, however, that the recommended voltage range starts at 7 volts. The Arduino specs don't say a lot about it, but if you use more than 12 volts to power the device, the regulator could overheat, damaging the board. The voltage regulator does have its own internal over-temperature protection, and this will shut it down when the temperature goes above 350 degrees or 175 Celsius. Once the temperature drops, the regulator automatically resumes operation. What this means is that powering the board improperly can not only damage it, but it can cause strange errors and failures as the 18MEGA328 microcontroller restarts. For most of us, when we put our finger on an object of about 150 or 65 Celsius, we will only be able to keep our finger on that for a few seconds before the pain sets in. This is a good rule of thumb for hobbyist electronics in general. If you can't touch it for more than a few seconds, it's probably too hot. The rules may be different if you're designing a commercial or industrial widget, which often have to stand up to harsher environments like under the hood of your car. Now, the Uno, being a low-cost open-source platform aimed at hobbyists, is not meant to stand up to temperatures much greater than that for very long. For a 12-volt input, the maximum regulator current using the above rule is only about 70 milliamps. Now, you might be thinking, how did I come up with that number? Well, I won't bore you with all that, but if you read the datasheet for the regulator and do a bit of math, making a few rough assumptions, of course, you should get something close. With a 12-volt supply, the max current, using our rule, isn't too much. The microcontroller itself draws about 10 milliamps at 16 megahertz. The USB interface takes another 15 milliamps, and the rest of the circuitry on the board, like the LEDs, etc., will eat up another 10 milliamps or so. Not much room for anything else here. So here's a takeaway. Use a power supply less than 12 volts. For example, using the same thinking that gave us a limit of 70 milliamps for the 12-volt power supply, we can raise that to about 250 milliamps if we use a 7-volt power supply. Don't have a 7-volt power supply? Then grab the closest thing to it. This type of precaution not only protects the 5-volt regulator, it also protects the smaller 3.3-volt regulator. And another word of caution is in order here. Watch your sources. Last time we mentioned that Arduino boards are open source, and since they are open source, anybody can copy the design and even alter it as they see fit, just like we discussed in the last tutorial. For example, some Arduino lookalikes don't have thermal vias, which are little copper line holes that conduct heat between the layers, so the regulator is likely to run hotter. One trick some people employ is to add a heatsink to the regulator. While this can help a bit, the case is made of plastic, which doesn't conduct heat away very well. Now, a minute ago, we talked about using a 7-volt or something close-ish power supply. But what if your project requires 12 volts or more? One way around this would be to use a separate power supply for the project. You can also feed another voltage regulator that produces a lower voltage with that 12-volt supply, with a heatsink if needed, and feed the Arduino with its output. For example, an LM317 regulator with a few resistors would produce 7 volts. Here's another good rule of thumb for those wishing to venture into this territory. When your power supply becomes more expensive or complicated than your Arduino board, it's time to rethink things. Going back to the specs here, we can see that the DC current limit for any digital pin is only 20 milliamps. This is barely enough to drive one LED. This is important because a microcontroller's output pin drivers have no current limiters. We'll talk more about I/O pin specs and characteristics in another tutorial. It's been said that too much power often corrupts people. Too much power can also corrupt your project and ruin your board, as we have seen. There is definitely more than meets the eye to powering the Arduino. You may be able to bend or even break some of these rules and guidelines we've discussed a few times, but if you do it often enough, it will catch up to you. You'll know it when the magic smoke appears or the board simply ceases to work. And if you're interested in Arduino microcontrollers, you'll also love how to get started with Arduino in 1 day or less. Get instant access now by clicking the link below in the description.